Alrighty, in this video, we are going to be talking about inverse functions. And as a reminder, the derivative of the inverse function is g prime of x is equal to 1 over f prime of g of x, given that g of x is the inverse of f of x. And given that, remember that the definition of an inverse function is this right here. So be sure to watch the previous video on how we got this in terms of the inverse derivative, because that's going to be important. So for number 1, or number 4 in this case, I want to find the derivative of the inverse function at 2. Now, as a reminder, this tells me that f of x has a y value of 2. And f inverse of x, the inverse function of x, has an x value of 2. Now, in order to figure out what the x value here is, we are going to substitute in 2 for y, and then we're going to solve for x. So that's going to give me 0 is equal to x cubed plus 2x minus 3. Now, here's a problem about this now. I can't factor this because this is a cubic. So the only thing that we can do at this point is probably use guess and check, and let's say the rational root theorem that you guys learned back in pre-calc. In this case, your possible factors are either going to be 1 and 3 because of this right here. And if you were to look at this pretty closely, you can see that it's going to be 1 because 1 cubed plus 2 times 1. That's going to be 3. 3 minus 3 is going to be 0. So that means that your x value is 1. Now, remember the reason why we did this is because that's going to give us g of x. And remember that g of x is the same thing as the inverse function of f. So if I wanted to find the inverse function, the derivative of the inverse function at 2, then this is saying g prime of 2 is equal to 1 over f prime of g of 2. Now, we know that this right here means that x is 2 for my inverse function. And then my y value is going to be 1. So what I'm going to do here is substitute in g of 2 to be 1. Okay, so once we have that, the next thing that we're going to do is take the derivative of f of x to figure out what f prime of 1 is. So the derivative of f of x is going to be 3x squared plus 2. And then if I were to take the derivative with respect to the value of 1, that's going to be 3, 1 squared plus 2, 3 plus 2, or 5. So this is saying that f prime of 1 is 5. I'm going to use substitution here, meaning that g prime of 2 is going to be 1 over 5, so 1/5. And remember that g prime of 2 in this case is going to be the inverse derivative at 2. All right, same thing for number 5, very similar. This is going to tell me that f of x has a y value of 0, and then we don't know what the x value is. Whereas f inverse has an x value of 0, and then we don't know what the y value is. All right, so this is going to be 0 is equal to x cubed plus x minus 2. Once again, I can't factor this, so using my rational root theorem, the only possible solutions would be 1 or 2. In this case, if you did 1, then congrats, because this is 1 cubed plus 1. 1 plus 1 is 2. 2 minus 2 is 0. So you get 1. Once again, we know that g prime of x is going to be 1 over f prime of g of x. And since I want to find the inverse derivative at 0, I'm going to substitute in my x as 0 to get that. I know what g of 0 is because remember g of 0 is the same thing as the inverse at 0. In this case, we found out that it was 1. So now I have g prime of 0 is equal to 1 over f prime of 1. Okay, guess what? We got to take the derivative now. And then we got to find out what the derivative is at 1, which you'll see will give us 4, meaning that g prime of 0 is 1/4. Or, once again, g prime of 0 is the same thing as saying the inverse derivative at 0 is 1/4. All right, number 6. We have the inverse. We want to find the derivative of the inverse at 3 if f of x is this lovely thing right here. So, once again, as a little comparison, f of x means that we have a y value of 3 and some x value that we don't know about. The inverse has an x value of 3 and then some y value that we don't know about. So for number 6, I'm going to set y equal to 3. Subtract.
Congratulations to Cat's Eye, the first girl group to have the door.
So that's going to give me, not y, 0. That's going to give me 1/4 x cubed plus x minus 4. Now, the problem is we have a coefficient of 1/4 in terms of my leading coefficient. Kind of don't want that, so I'm going to multiply my equation by 4. That's going to give me x cubed plus 4x minus 16. All right. Now, this is going to be a little bit harder because 16 has multiple factors. Using your rational root theorem, that's going to be plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, and then plus or minus 16. That's 1, 2, 3, 4, 5. That's 10 choices, and that's a lot. So hopefully you could guess and check pretty well in terms of this. And if you do, x is 2. All right, at this point, you have x being 2. So your derivative is this. And we want to find the derivative at 3. So we have g prime of 3 is equal to 1 over f prime of g of 3. We figured out that g of 3 is going to be 2. So now I have g prime of 3 is equal to 1 over f prime of 2. And then we just got to figure out what f prime of 2 is. So in this case, I'm going to have 3/4 x squared plus 1. I am going to plug in 2. So that's going to give me 3/4 times 4 plus 1. And that's going to give me 4. So this is going to give me g prime of 3 being 1/4. Or the inverse derivative of x at, the inverse derivative of f at 3 is 1/4. All right, so I'm going to do number 7. These are going to be the same thing. And we'll probably do a couple of these during class. So like 8 through 12. Probably don't do these yet, but if you want to do them, then you can. But we'll just have these during class. All right, for number 7, I want to find the inverse derivative of f at 3. So once again, I'm going to create my little info on what I know. So I know that y has to be 3 for f of x. And then for the inverse of f, I know that x is 3. All right, so now what you're going to do, of course, is to set your lovely equation equal to 3 and then solve it. So you're going to get 3x minus 6 is equal to x plus 6. You're going to get 2x is equal to 12, which means that x is equal to 6. So that means that this is 6 and this is 6, which is going to be important because remember now, g prime of x is equal to 1 over f prime of g of x. We're to figure out what g of x is. In this case, it's 6. So now I have g prime. Oh, wait, let me actually put this in first. G of 3 is going to give us 6. So now I have g prime of 3 is equal to 1 over f prime of 6. And then you are going to internally cry a little bit because now you got to figure out the derivative of f of x at 6. So low d high minus high d low all over low square. You're going to plug in 6. So you're going to have 6 minus 2, which is 4. 6 plus 6, which is 12. 6 minus 2 is 4. 4 squared is 16. So you have 4 minus 12 over 16, negative 8 over 16, which is negative a half. So that means that f prime of 6 is negative a half, which means that g prime of 3 is going to give us negative 2. So this tells me that the inverse derivative of f at 3 is negative 2. Now, once again, if you want to, you can interchange x and y and then solve for y for some of these. Now, something like number 4, 5, and 6, you probably can't because you can't complete the square or anything. For number 7, you probably still can't either. Is it possible? Maybe. Whenever you switch x and y. Now, if you can't switch x and y and then solve for y and take the inverse derivative, then obviously just do the steps that I've outlined for you, where you solve for x by substituting in y here into your equation. That's going to give you the y value of the inverse of f, which then gives you this lovely thing right here. And then you got to take the derivative of f of x, figure out what that is, and then use that to help you with your final answer. All right, as for now, keep 8 through 12 blank because we are going to do that together in class. And then I'll probably give you something else in class once we finish this.